bringing a 167 car long double stack train down Cajun Pass. I don't know where that is, but that's a really long ass train. 60 to 70 miles an hour. Ooh, fun. It's freakishly fast for a railroad. Yeah, now that you say that, especially for like 160 trains doing that, yeah, that's kind of crazy. How many hundreds of tons, you know, are going that speed? The amount of energy that train has. It's gonna take a lot to stop it. How much do those containers weigh? It's about 1,250 tons. Look, let's just do some basic math, alright? So let's say it's moving 70 miles an hour, right? So 70 miles an hour times 1.61. So that's 112 kilometers an hour. So if we want to divide that or multiply it by divide it by 60, right, to get it to kilometers a second. Yeah. And then you want to multiply it by 1,000 to get it in meters per second. No, that's definitely not. It's not moving 1,878 meters per second. I gotta do some dimensional analysis here. This is where I usually write it out. 70 miles an hour, so it's 112.7 kilometers an hour. So yeah, I have to multiply by 1,000. Yeah, okay. Multiply by 1,000 to get it in meters per hour. And then I have to divide that. Oh, I have to divide it by 60 again. That's what it is. Divided by 3,600. There we go. 31.3 meters per second. All right, 1,250 tons times 2,000 pounds. 250,000 pounds. There's 2.52. It's 2.2, right? It's 2.2 pounds per kilogram. So I have to divide that by 2.2 to get it into kilograms. And then we do the good old 1/2 mv squared. 1/2 times mass times velocity squared. 556 million joules of energy. Yeah, that's a lot of joules. That's a lot of joules. That's an insane amount of energy. Yeah, you want to squish something? Just stick it in front of a 556 million joule train, and it'll get squished. Well, to tell you the truth, it'll get a lot more than squished. Puree. Yeah. Object plus 500 million joules equals no more object. Today we're learning how to turn a Lucas's law. Yes, that's my law of physics that I'm gonna write. 500 million joules plus object equals liquid. The train would not fare any better. True. I mean, we are thinking if we convert all of the kinetic energy into an object, right? I mean, you could do some basic momentum conservation. How how fast would you be going after the fact if it ran into you? Just do mass times velocity equals mass times velocity plus mass times velocity. Yeah, if you wanna import all of the kinetic air, let's do some let's do that. Okay, right? Right, so if I take its mass, which was this much, times its velocity, right? And then I wanna figure out how much velocity that is me. Right, if all of the energy, obviously, like less than 1% of the energy in the collision is actually going towards you. But theoretically, could you leave the atmosphere? I'm about to answer that question. So I have energy equals mass times velocity, so velocity, I just have to divide by my mass, which is like 70 kilograms. I would be moving 840 meters per second. I mean, that's only Mach 2.5, so no. You'd be earthbound over there, and up there. Yeah. Become widespread news. Like, that's assuming an elastic collision. Right, like, all of the energy is ported onto the other. But that's not how that happens, right? So you'd have to... It's just a conservation of momentum, right? MV initial plus MV initial equals MV final plus MV final. Doesn't it make a difference if the surface areas that are contacting? Yeah, and it makes the impulse of the thing, right, and how much energy is transferred. Really, you can assume that it's an inelastic collision, right? Meaning that the two of you are going to be stuck together. Like, that's what's going to happen. So you are going to be moving the velocity of the train afterwards. You're not going to get, like, launched like the movies, right? You're not like a baseball. You don't rebound. That's a whole nother part of the equation. It's just a bug on the windshield, right? That's what it is. Like, you're going to slow the train down by like 1/8 of a meter per second. Meanwhile, you get accelerated at like 50 Gs. Either way, there was one thing to know. You will be very, 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 very dead. And all over the place. Thank you for coming to my TED Talk. That right there is a YouTube clip.